Okay, here's problem number 5. When I worked this exam, I wasn't quite sure how to explain this problem, so I actually skipped over it and am working it last. You should do the same on your tests. If you're not sure about a problem, especially the lesser problems, don't spend a lot of time on it. If you waste time there, you won't get points on the more valuable problems. So let's try and work this a little quickly here. First time I did it took me 8 minutes. This time I'm going to just sort of logic rather than try and write everything um, out and do a bunch of conversions. So we're given the volume of the moon in cubic kilometers, and we want to determine the volume of a 1,000 kilometer equals 2-inch scale model and give the answer in cubic inches. Okay, so we're creating a small model of a large object. So we're scaling this volume, oops, wrong button. We're scaling that volume down by 1,000 kilometers equals 2 inches. Okay, so these scales are linear scales. When we're dealing with volumes, we're going to have to cube them. Okay, so the way I'm going to write this is I'm starting off with 21.9 times 10 to the 9th kilometers cubed. And my scale factor is for every 1,000 kilometers, I have 2 inches. So there's my scale factor. Okay. So obviously 1,000 kilometers is not equal to 2 inches, but this is our scaling factor. So we can write it like that. And we still have to account for the fact that we're dealing with volume. So that's all this problem's really looking for, is for you to recognize that. And let's see, 21.9, and use e to the 9th. Okay, and then I'm going to multiply that by the quantity 2 divided by 1,000 cubed. And I get 175.2 cubic inches. About 175 inches cubed. And the point I want to make is, if you're not sure about a problem, write out some initial work. Don't spend a lot of time on it. Come back to it. Also recognize that problems that only have a value of a few points are intended to be short problems. So if you find yourself doing them and spending too much time, you've probably missed an easier method of working the problem.